Polarization, home of the MC Emacs. I'd like to thank you for joining us as we continue along in our presentation series. Once again, I have Noah Bethel, the Vice President of Product Development.
Hello from sunny Tampa, Florida.
And yes, it is sunny today, Noah.
It is a nice
good
day.
call on that one.
Yes.
Every now and then, a blind squirrel gets it.
That's right.
And I am Todd Gunderson, the Vice President of Sales and Marketing. And Noah, we're excited to we've been doing a lot of podcasts, but now we want to kind of get back into the data side of things. A new case study came in front of us, so we decided to put it together and share it with our viewers.
Yeah, we solved the mystery of electric motors. Now we're looking for the mystery of a Delta startup.
More mysteries.
There's always mystery.
We're the Sherlock Holmes of motor testing. And, it works. We don't often mention this, but you're an ex-nuke electrician. I'm an ex-nuke electrician. So
yeah.
That's what our that's what they told us to do, right?
Investigate.
Don't just take it at face value.
Ask questions.
Ask exactly right. Ask questions. Try to get to the bottom solution, right? So here it is, Delta start and run. So it's not a Y start Delta run.
Good point. Yeah, a lot of industry in the event of lower voltage and higher horsepower, they will, in an effort to reduce the impact on the distribution system bus voltage, they'll actually install a Y start Delta run. In this situation, there's no Y start, just straight Delta.
Yeah, and they put the Y start in there because it's like a third less of the voltage and a third less of current at startup, so that it can handle that.
Significant increase in the winding impedance, drops the current to a controllable level, still maintains good torque. So you get the motor started without shutting the plant down practically, and then
transition it over to Delta.
Exactly.
And then it goes on its merry way. So where the Delta connection is set up in the MCC or in the motor, it actually makes a difference.
Can make a huge difference. A lot of times when a motor gets sent back to you from the shop, it's not pre-wound one way or the other. It has a variety of voltage configuration possibilities, and they'll leave the windings hanging out of the motor so that you can connect them in the way you want.
Perfect. This is a 200 horsepower, 226 full load amps, 4-pole motor at 460 volts, 480 volts with a frame number B447T. So we're talking, once again, this is a pretty significant size, but one that you could probably get away with doing a Delta start, Delta run. So this is the motor we're talking about. And now, mind you, these fail frequently. They call them, they're fan motors designed to cool off, obviously, cooling towers. And
right,
things like
pretty
that.
standard. In fact, 200 horsepower motor for a cooling tower is a decent size. This is not a small utility plant.
So, like we mentioned, they fail. 3 of these things fail annually. So it's not they're 200 horsepower. So those are expensive motors.
This is excessive. This is not what you'd expect. I mean, these a lot of times are gear driven. There's gears in between the motor and the fan. Not exactly sure about this application, but they change from location to location. But 3 times a year is a lot.
Yeah. So they were connected Delta in the MCC itself, not at the motor, and the motors are about 1,400 feet from the MCC. So we're introducing this parallel cable all the way through that 1,400 feet.
Right,
correct?
and even worse than that, they're doubling the series flow of each phase-to-phase connection. Right, so you're going from phase A into the beginning of winding, A, back to the starter, and then back to the motor again just to get to B. It's really not a good idea.
Right. So, and then it was creating a high resistance imbalance in the when they did the standard test. So if we look here, here's the startup prior to the correction. So you can almost see separation in the currents. Not all of them are starting up at the same level.
Right, and not for a short period of time. You do expect a little bit of variation for the initial, what we call the magnetization current or whatever, but we're talking 3-4 seconds of really high variability in the current from phase to phase.
And when we come over here to our this is probably the most telling because there's a significant amount of noise in the circuit.
Yeah, it makes it very difficult, specifically for machine train analysis. So you've seen some of the case studies in the past where we were used this exact test to identify, gear issues on the cooling fans.
And
hard to do it now.
Right, and so sorry for
okay.
cutting you off. I've often heard you say the number one killer to an asset is heat. All of this harmonics, whatever junk you want to call it, noise, is creating excess heat in the cabling, or
Anytime we talk about power quality issues, be it harmonics, imbalances, things like that, it's directly applies to the heat increase in a motor. So if you're way underloaded, which they're not going to be on cooling towers, but if you were, then that wouldn't be as big of a deal. If you're anywhere near full load, now you're just adding excess heat. That's not doing any real work.
almost like on our power test, we have the fundamental voltage and the fundamental current, which is essentially the 60 hertz signal. But then we also have total, and that's a combination of all the harmonics.
Right,
that
complete
exist,
addition all the way to the top.
could exceed the FLA or
Absolutely.
the voltage. So here's your polarization index, and this is really just highlighting, this is from the starter, on what it looks like when you incorporate all that cabling down to the motor. Because when you disconnect it from the motor, it's probably 6 times, 7 times more resistance to ground capable.
Correct.
than
And
what this
historically,
is.
that is the case, that the motor itself has a better insulation to ground than the cable run. And the longer the cable run, guess what? The more parallel path to ground and the lower the values.
Yeah, more opportunity to get dirt, to get some kind of moisture intrusion into it. All of that matters when you're putting it. So once, like we said here, huge difference. You're going from 300 meg, and it's starting out at 20 gig ohms.
Yeah,
so
that's
it's
a much
pretty substantial.
much improved. Yes,
Yeah.
and it focuses our attention back to the long cable run as the minimum. Doesn't mean we're not outside the IEEE minimum,
Yeah,
but
we're
it's
still
something
above
to
it.
pay. Exactly.
But you introduce opportunities for problems. Now here's the standard test, pre and post correction. So we're here. We see the 41% resistive balance, 13% inductive imbalance, and we're testing from all over the place. At the motor leads, we know it's good. So
Right.
if we're just testing at the motor on March 7th, everything looks pretty good with the motor. So we know there's not a real issue with this motor. However, when you're going from the MCC, you can see we have some issues.
If there's ever a reason that we say red is bad, this is it. 41% resistive imbalance, even if that's primarily, a DC component of your overall impedance value, it will cause a difference in your current. That is a huge resistive imbalance.
Right. And it's not ideal. We're still at 5%, 8% after the fix. But what are some things that we could do maybe to help eliminate some of that resistive imbalance?
So they've moved the basically the delta connection all the way down to the motor. They've removed 1,400 feet of variable resistance in between. It's a great thing. So at this point, I think that it would be wise to connect it to the motor, do motor only test compared to the cables. These are things that they can do even from a thermal issue. Try to take a look. Things that they can do to try to further identify. Because keep in mind, once you get to the motor, a lot of times there's dual cables. Even though they established a delta connection at the motor, there's still parallel phase connections going out to the starter. Well, let's say that one of those cables might have over 1,400 feet, one cable can be slightly different. It'd be worth taking current ammeters, take your Emax test, get on those two cables and see if there's a different flow from one cable to the other. You may find a situation where the large majority of current is flowing through one of the two parallels, in which case it's going to significantly increase the resistance of that conductor. And that could relate it to a 5% resistive imbalance.
Okay, those are all good ideas that you can add into this. Here's the inrush test post repair. Still kind of the same amount of time, but we're not really showing any noise level on the actual.
And look at the
startup.
lack of differential. That was they're literally on top of each other, and that's ideal.
Yeah, and here's at the actual starter itself, we have all the different cabling there.
Right, 6 leads, and what do you want to do with them? Well, this is where the delta connection will occur. Right, we could form this delta connection here, and then the dual cables that we're traveling 1,400 feet can just be a parallel lead, leading to each phase.
Right, which is what it looked like here. You can see the two. This is at the MCC.
Right.
So those are two connections there, correct?
Correct.
That's going all the way down to the actual motor.
Exactly.
And then just visual signs, right?
Yeah, that's
Heat is a negative thing. It destroys the insulation. We have classifications for insulation, Class B, Class F, Class H, and when you exceed it by a certain temperature, 10 degrees Celsius, you kind of reduce the life of that electric motor by half.
Oh, yeah. I mean, you look at this and you're a little surprised even that the resistance to ground we had was as good as it was. And that's because it's all happening at the end turns where it's not actually on the core.
Yeah.
You know, there's laminations. There's a paper, thermal or insulating paper that is keeping it from ground.
Yet.
Exactly. But you're looking at this motor the life expectancy is very, very short.
Right. And so every time one of these fails, if it goes in for a rewind, $30,000. If you need a new one, $24,000, but a 9-week lead time, which means you shut down the plant or you lose capacity of the plant for 9 weeks, which capacity could be as much as $30,000 a day. So you try to get it rewound, and then the classic, what do we always say? Call PDMA before you call the crane, because cranes are expensive.
They are.
$15,000 for removal and replacement.
Wow.
And that's probably just a couple hours to get that big, heavy 200 horsepower motor into place.
And imagine, now what's interesting is the downtime. That's a big loss. They estimate about 10% of the lifetime cost of a motor's downtime. And if you have 3 failing a year, that might be higher.
Yeah. When you start to lose $30,000 a day, we're not all made out of money.
No.
There's, prices are going up. So you want to be able to be fully in full capacity.
Absolutely.
Well, Noah, thank you for sharing your information with us, your wealth of knowledge. And as always, thank you, the audience, for listening to us. And as always, if you have something that you'd like to share with us, please reach out to us. You can call us at 813-621-6463, or you can send us an email on www.pdma.com. We're always looking for new information to be able to share with the peers out there, with our customer family. Until we hear or see from you again, or see you at a trade show, stay safe and have a great day.